State the type of bonds that exist between the following compounds. So we have the first compound, which is hydrogen. So once you have been given this, just write the chemical symbol of hydrogen. Then ask yourself, is hydrogen, these are two nonmetals. So if these are two nonmetals combined together, then that one is covalent bond. Next one, hydrogen chloride. What type of bond is here? Is it covalent, dative, or ionic? So write HCl. So this one is HCl. These both of them are nonmetals. If they are nonmetals, you can see this one is hydrogen, and this one is. So will they undergo ionic, covalent? So because they are nonmetals, they will undergo covalent bonds. Nitrogen, N2. Is it covalent, dative, or ionic? These are two nonmetals, nitrogen plus nitrogen, nonmetals. Therefore, the bond is covalent. Potassium fluoride, Ki. This is a metal and this is a nonmetal. What type of bond is that? Ionic. Magnesium oxide. That is magnesium oxide. A nonmetal, a metal, ionic. Sodium oxide. Sodium oxide, a metal, a nonmetal, ionic bond. Water. Water is an nonmetal, therefore covalent bond. Covalent bonding. Carbon 4, CO2, nonmetal, covalent. Like that. Carbon 2 oxide. Is this covalent, dative, or ionic? We said all nonmetals, they undergo covalent except this. This one is dative. We shall draw it and then you will see. What about pH? This one, I said whenever you see the positive sign there, always know that one is dative. Aluminum chloride dimer, you should always now master that this one is dative. Although it doesn't have the positive, it is a metal and a nonmetal, aluminum and chlorine. It is unique and it undergoes dative covalent bonding. Hydroxonium ion, it has a positive, therefore it is dative. Ammonium ion, it has a positive sign, therefore it is dative. So this is how you identify the type of bonds that is found between the elements that are forming a compound, as simple as that. Using a dot and a cross, draw the diagrams for the following compounds. So the first thing you need to identify is that this is hydrogen, therefore it will undergo what it will contain, what we call covalent bonding. It will have covalent bonding. So one hydrogen, remember we use the outermost energy level. Whatever we draw the outermost energy level, will combine, will share electrons with another hydrogen atom. Remember this one has got 1 electron and this one has got 1 electron. So none of them is willing to give the other one. Therefore, this atom here will provide 1 electron and this one will provide another electron to be shared, and this one now they are step. This one is step 1, 2, and this one is step 1, 2, and this one can be represented as hydrogen, a single bond hydrogen. A dash represents a single covalent bond which has 2 electrons. This means X dot. A single dash means 2 electrons, like this. Hydrogen chloride. So there we will have hydrogen the outermost energy level, and HCl, chloride ion. So chlorine is atomic number 17. So in the outermost energy level, you write electron configuration. Chlorine has 7 electrons in the outermost energy level, and hydrogen has only 1. So this one has 1, 2, 3, 4, 5, 6, 7. Right? So what happens is that this one needs 1 to be stable. This one needs 1 to be stable. So there's no atom which is willing to give electrons. So therefore what they do, they share electrons. So chlorine provides 1 electron here. This one brings another electron here. So hydrogen now is stable. They cannot share anymore. Now we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. Chlorine is stable. 1, 2, hydrogen is stable. And this is the covalent bonding of hydrogen chloride gas. You can also represent this as HCl, a single dash. So 2 atoms of nitrogen plus nitrogen forms nitrogen 2. So they covalently bond like this, forming a bond. So how do they do that? Nitrogen is atomic number 7. So this one in the outermost energy level has 5 electrons, 2 to 5, 2 to 5. So these are the bonds that are involved in bonding, like we said. So what happens is this. So nitrogen, we consider the outermost energy level. This outermost energy level in nitrogen has got 5. So another nitrogen has 5. So this one has 1, 2, 3, 4, 5 in the outermost energy level. This one has 1, 2, 3, 4, 5. Each of them needs 3 electrons to be stable, and none of them is willing to give out the electrons. So what they do, they start sharing the electrons. So this one provides 1 electron. So this provides 1. This one provides 1. So once you provide, you cancel that one out, you remove it like that. So how many are remaining? 1, 2, 3, 4, 5, 6. We need a stability of 8. Therefore, they are not yet stable. So they continue sharing. This one also provides again another one. This one provides another one. Right? You count 1, 2, 3, 4, 5, 6, 7. Not yet stable. 1, 2, 3, 4, 5, 6, 7. Not yet stable. So they continue sharing. This one also provides another one. And this one provides another one. So here, the remaining electrons, you put them inside. The remaining electrons, you put them inside. So now we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So let me draw this one here clearly. Nitrogen. Another nitrogen. So this one, 1, 2, 3, 4, 5, 6. This one, 1, 2, 3, 4, 5, 6. Is it 6 or 5? They are supposed to be 5 in the outermost. So 1 brings 1. This one brings another one. This one brings 1, 2, 3, 4. 1, 2, 3, 4. So brings another one. Brings another one. 1, 2, 3, 4, 5. 1, 2, 3. So we have 3 of them. 3 covalent bonds. 1, 2, 3. So now this is nitrogen. Like that. Water. So water, now we see we have 2 hydrogen atoms surrounding 1 oxygen. So make sure that the atom that is single is at the middle, and then it is being surrounded. The 2 will surround the single element. So here oxygen will be at the middle. Oxygen. then it will be surrounded with 2 hydrogens. 2 hydrogen. So hydrogen, hydrogen. So this is water. Oxygen is atomic number 8, so it has 2 to 6. So here oxygen has 6 electrons outside. 1, 2, 3, 4, 5, 6. Hydrogen has got only 1. So oxygen is not willing to give electrons, hydrogen is not willing to give, so they share. So this hydrogen brings its electron inside here, and this one provides another one to be shared, so one is removed there. So hydrogen here is stable already. This one brings its electron there, and this one brings another one here. So, and then the remaining 1, 2, 3, 4, you put them here. 1, 2, 3, 4. So if you count for oxygen, 1, 2, 3, 4, 5, 6, 7, 8, oxygen is stable, hydrogen is already stable, 1, 2, 1, 2, and this is water. So it can also be written as oxygen, hydrogen, hydrogen, single, single covalent bond. This one is also a way of representing this one. Carbon 2. So carbon is a single element, atom here, so it will be at the center. Oxygen will surround it. So draw this carbon. It will be surrounded with 2 oxygens. So this is oxygen, oxygen. Carbon is atomic number 6, so it has 4 electrons in the outermost energy level. 1, 2, 3, 4. Now that I have used X for carbon, I will use dot for oxygen. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Remember, oxygen is atomic number 8. That is 2 to 6. 2 to 6. This one is 2 to 4. We consider the outermost energy levels only. Outermost energy levels. So what will happen? Carbon is not willing to give electrons. They cannot give. So this one, oxygen, also needs 2 to be stable. Carbon dioxide needs 4 to be stable. This one needs 2 to be stable. So there's no atom here that is willing to give. So they end up sharing electrons for them to be stable. Therefore, carbon provides 1 here. Oxygen provides 1. Right? We go to this side. This provides 1. This provides 1. So if you count for this now, 1, 2, 3, 4, 5, 6, 7. I'm not remaining, there were 6. There were 1, 2, 3, 4, 5, 6, 7. For this, 1, 2, 3, 4, 5, 6, 7. It means it is not stable. So this one also brings another one here. So we start here. Another one here. This brings another one here. This brings one here. And this one here. So now 1, 2, 3, 4, 5, 6, 7, 8. Carbon is stable. Oxygen, now the remaining electrons, you put them inside. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So now 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is stable. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen is stable. 1, 2, 3, 4, 5, 6, 7, 8. Oxygen. And this one is covalent bonding now. This is what we call covalent bonding. So make sure these electrons, they don't touch this one, because this thing must be very clean. If you put some dots like this inside there, they will be counted as electrons. So we are supposed to use dot and X to draw the structure of ammonia. So before that, you should know that ammonia forms covalent bonds, because this is an nanometal and this is an nanometal. The nanometal, which is single or one of them, it stands at the center, and then those that are more than one surrounds it. So nitrogen will be at the center, and then will be surrounded with 3 hydrogens. 3 hydrogens. Hydrogen, hydrogen, hydrogen. Hydrogen has got 1 electron. Hydrogen has another 1 electron. Hydrogen has 1 electron. Nitrogen is atomic number 7, so it is 2 to 5. So 2 to 5, the number of electrons in the outermost energy level are 5. So here we have 1, 2, 3, 4, 5 for nitrogen. So they start sharing. Hydrogen provides 1 electron to be shared here. Nitrogen provides another one. Hydrogen provides 1 here. Nitrogen provides another one. This hydrogen provides this one. This one provides another one. So 2 are left. So you put them inside here. So by so doing, and this is the correct formula for ammonia, the correct structure for ammonia gas. How else can you put it? You will put nitrogen, hydrogen, 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 because this single line represents 2 electrons, these 2 electrons, so it is a single covalent bond. So this one also, this one is as the same as this. Phosphine, I want you, this is your homework. You draw that. Let me draw this. Carbon is surrounded with 4 hydrogens to form methane. So we draw it like this. We put carbon at the center. Then we draw the outermost energy level for carbon, which has 4 electrons, surrounded with 4 hydrogens. 1, 2, 3, 4. Hydrogen, we know it has 1 electron. Carbon, we know, has 4 electrons in the outermost, because carbon is atomic number 6. So electron configuration is 2 to 4. So the outermost, it has 4 electrons. Hydrogen has 1. So this electrons is for carbon, 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 carbon. There are 4 of them. Hydrogen has got 1. Hydrogen has 1. Hydrogen has 1. So they start sharing, because hydrogen cannot give electron to they cannot give carbon electrons. Therefore they end up sharing. So this one will provide 1. Carbon will provide 1. Hydrogen will provide its own. Carbon will provide its own. Carbon will provide 1 here, and this one will provide its own. This one will provide this, and this one will provide this one. So you realize now without this darkness, now you can write this. Write it here: carbon, hydrogen, and this is what we call methane structure. So how else can you present it? You put carbon at the center, a single covalent bond like this. So this one also means this. So we have many others. You will try to draw the structures for them. Using dots on the cross, draw the diagrams of the following compounds, the structural diagrams for this. So this carbon 2, I told you carbon 2 is one example of a compound that undergoes dative bonding. So let us see how dative comes in. So carbon, and then oxygen. So we know oxygen is atomic number 8, so it has 2, that is 2 to 6. It has 6 electrons in the outermost. Carbon has 4. So here carbon has 1, 2, 3, 4. Oxygen has 1, 2, 3, 4, 5, 6. Right? So they start sharing. Carbon provides 1 electron. Oxygen provides another one. Yes. So when you count 1, 2, 3, 4, 5, 6, 7, oxygen is not yet stable. 1, 2, 3, 4, 5 is not yet stable. And then, so they share this one, this one. Very good. So here they are left 2. Here we have used 2. So here now, oxygen is 1, 2, 3, 4, 5, 6, 7, 8. Oxygen now is stable. And carbon is 1, 2, 3, 4, 5, 6. Carbon is not yet stable. So now look, if we continue sharing, if I remove 1 here and put it inside here, oxygen is going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. And the electrons in the outermost energy level, they're not supposed to go beyond 9. At this point now, we have 2, this one which are remaining here for carbon. Now this is the point where oxygen brings in its own pair to be shared. 1, 2. Brings in a pair to be shared. So now that's where dative bonding comes in. So when you count now 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Each atom is now stable. Now when we can draw this one in a different way also. We can have carbon, oxygen. So which one is going to give electron? So this they will 1, 2. The sharing is 1, 2, 1, 2, and then oxygen is going to give electrons. Now we use this arrow. We use an arrow, meaning that this is a dative bond where oxygen gave a pair of electrons to be shared. So this one also, yeah, we can have 2 of them here and 2 here, and that is all. We have formation of this. This is phosphorus and this is hydrogen. Now whenever we have hydrogen, 4 of them, and it has a positive sign, it simply means that one hydrogen in this compound is empty. Empty meaning what? When a hydrogen loses an electron, it becomes positively charged. So when it is positively charged, it means that one hydrogen inside here is empty. That's what it simply means. So if that is what it means, I just want to go straight and draw this one. So phosphorus is atomic number 15, P is equal number 15. So that is 2 to 8 to 5. Meaning outermost energy level for phosphorus, it has 5 electrons. So we will draw that. Phosphorus surrounded with 4. 1, 2, 3, 4. Hydrogens, hydrogens, hydrogen, hydrogen. But I have told you, out of the 4 hydrogen, 1 is empty. Why is it empty? Because it has a positive sign, meaning 1 hydrogen lost an electron. So hydrogen has only 1 electron, and when it is positive, it means 1 electron is missing. Therefore, we can decide to put this one positive, so that we ensure that this one is empty. Right? So this one does not have any electron, but this one has got 1 electron. This one has got 1 electron. This one has got 1 electron. Phosphorus has how many? 5 in the outermost energy level. So phosphorus has 1, 2, 3, 4, 5. Right? So phosphorus, hydrogen, the one that has got electron, they start sharing. Hydrogen provides 1. Phosphorus provides 1. Hydrogen provides 1. Phosphorus provides 1 here to be shared. This provides 1 phosphorus. Hydrogen provides what? Provides 1. Now, phosphorus has got a pair of electrons which is unused. And then now we have empty hydrogen. So what happens is that phosphorus decides to provide this pair of electrons to be, because these electrons we are going finally to put them inside here. Now we can put them here in phosphorus 1, 2. Phosphorus will be stable, these 3 hydrogens will be stable, but this one will be empty. Now phosphorus decides to provide, to give these 2 electrons to be shared here. And by so doing, every atom becomes stable. And since it is an ion, we finally put it like this, showing that it was an ion. So I want to now put it here very clean without this darkness. So we will put P, because this needs to be very clean without any. Now when you have done that, now you can put your very clean diagram here. Very clean, very clean, very clean. Now that you know how it should look like. And then this is hydrogen, positive, hydrogen, hydrogen, hydrogen. So here we have said it is going to receive 2. This is X this, X this, X this. So by so doing now, this is what is required. I have this one I did to show you. So this that is not allowed. When you use it, you must use a pencil so that you can erase everything. In this idea, we don't need any dot, because any dot inside here will be counted as an electron. We have aluminum, which is also undergoes a dimer, which is also undergoes forms a additive bonding. So I want you to try to draw this one, because it is also in Form 2 book. But I want you, Form 2, they have used this aluminum. They have used something like this. They have chlorine, 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 chlorine. You have seen them draw things like this. In Form 2, we have those things. But I want you to use this method to draw aluminum dimer. When you get stuck, you will always consult. We are available. 1, 2, 3, 4, 5, 6. Very good. Hydroxonium ion. This is how it is. This is water with one hydrogen that is empty. This is simply water plus empty hydrogen. That's when there are 3, and the positivity means this hydrogen is empty. But this hydrogen in water, 2 of them, they have, each of them has got an electron. So we put oxygen at the center. Oxygen at the center. Then we surround that oxygen with 3 hydrogens. 1, 2, 3. But 1 hydrogen is empty. But there are 2 of them has got electrons. 1 of them has electron and another one. Oxygen has 6 electrons. 1, 2, 3, 4, 5, 6. We know hydrogen is 2 to 6, so outermost energy level has got 6 electrons. So this one shares 1. Hydrogen provides 1. This one provides 1. Hydrogen provides 1. But this one does not have an electron to be shared, because it is positive. It means it had lost its own 1 electron. Therefore, oxygen provides a pair of electrons to be shared. So this one provides 1, 2. And like here, you see it is X dot. But here it is X dot dot, meaning these are the electrons from oxygen. Right? And then we put the remaining, this one here. So when you count now, 1, 2, 3, 4, 5, 6, 7, 8, oxygen is stable, and all the hydrogens are stable. Because it is an ion, we put a positive there to say that it is an ion. So we don't want to see this dot. We don't want to see this dot. So therefore, you need to draw it very clean here. You draw it very clean here by doing that oxygen. Make sure it is very clean. We need clean work. There are 3 of them. So hydrogen, 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 which is empty. So here you put a positive. And that is what we call hydroxonium, drawn very correctly. So like that. So I want you to draw for ammonium ion. and then I will mark for you if you want.